Have you ever wondered why giant boats and ships that can transport several hundred tons float perfectly while little pebbles, and maybe your phone if you've ever dropped it in the water, sink straight to the bottom? This fluid dynamics topic is described by the buoyancy force. Buoyancy is the upward force that an object feels from the water when it's compared to the weight of the object. It is what makes an object sink, float, or remain neutrally buoyant in the water. Neutrally buoyant basically means that it doesn't sink or float, it just stays in the middle. We will discuss later how this is useful for things like submarines. When an object floats, the upward buoyant force exerted by the water is greater than the downward force of the weight of the object. This can be explained by Newton's second law, which states that every action has an equal and opposite reaction. The first force in this reaction is the force of gravity pulling the object, for example your phone when you drop it in the ocean, down. This is the weight of the object. To be exact, it is the mass times the acceleration due to gravity. As most of us know, it is expressed in newtons. The other force that counteracts this force due to gravity is the buoyant force. This force is a little bit more complicated to understand. Basically, it's the weight of the exact amount of liquid that's displaced by this object when it's submerged. It's also measured in newtons. The buoyant force on an object acts through the center of buoyancy, which is the same as the centroid of the displaced volume of the liquid. This is because the force of gravity on the object acts through the object's center of gravity. Since these actions must be equal and opposite as stated by Newton's second law, the buoyant force has to be beneath the center of gravity. So, when an object sinks, the weight of the object is greater than the upward buoyant force exerted by the water, and its density is greater than 1 gram per centimeter cubed. When an object is neutrally buoyant, meaning it neither sinks nor floats, then the weight of the object is equal to the upward buoyant force exerted by the water. So, back to the neutrally buoyant topic. This is obviously useful for submarines, as they would need to first float as they travel out into the ocean, and then they would need to sink to get to the bottom of the ocean to explore, and lastly, they would have to float back up to the surface afterwards. Unlike a ship, a submarine can control its buoyancy, thus allowing it to sink and surface at its will. To control its buoyancy, the submarine has things called ballast tanks. These tanks can be filled with water or air. When the submarine is on the surface, the ballast tanks are filled with air, and the submarine's overall density is less than surrounding water, which allows the buoyant force to keep it afloat. As a submarine dives, the ballast tanks are flooded with water, and the air in the ballast tanks is removed from the submarine until its overall density is greater than the surrounded water, and this allows the submarine to sink. A supply of compressed air is maintained aboard the submarine in air flasks for its use with the ballast tanks. When the submarine is ready to go back up to the surface, that compressed air flows from the air flasks into the ballast tanks, and then the water is forced out of the submarine until its overall density is less than the surrounding water. It's a shame that my phone couldn't do that, or that my phone also isn't waterproof either.